Hi, welcome to lesson number 3, module 8 of the Big Data and Hadoop Developer course. So in this particular lesson, we'll be learning about the Scoop workflow. So in the previous lesson, we have learned how Scoop works and what does Scoop provide and how exactly the import works. We saw the behind the scenes of what is happening when you do an import. So in this lesson, we'll see the internal workflow, architecture, and the limitations of Scoop. So if you look at the internal workflow of Scoop, when you try to import a table, that is when you want to copy the table from the RDBMS to Hadoop, as a first step, Scoop will ask for the metadata to the relational database. Then the RDBMS will return the metadata of the table or even the database that you're trying to import. And based on the metadata, Scoop will generate the Java class. And based on primary ID, partitioning happens in table as multiple mappers will be importing data at the same time. So Scoop will look at the primary ID and as per that it will partition the data. However, you can also manually mention the number of mappers you need in case you want to specify that while the import process happens. Let's understand this in more detail as this is the crux why Scoop works faster than any other importing technique and how it is working. So here you can see an internal workflow example of Scoop. So as you can see, there is a table which has employee ID in the first column, first name in the second column, last name in the third column, and the manager in the last column. Now, if you look at the particular table, we have 10 entries, and when you ask Scoop to do an import, it queries the RDBMS for the metadata, and the resulting Java class will decide how many mappers will be needed to import this data. So just for the pictorial representation purpose, I have demonstrated here that there will be 4 mappers, meaning employee ID 1 to 3 will be handled by mapper 1, 4 to 6 by mapper 2, 7 to 9 by mapper 3, and 10 by mapper 4. However, please note that in the real world, there will not be 4 mappers for a simple import of 10 rows. Scoop is intelligent enough to understand the size of your table and divide it whenever is required. If you import 10 rows in a real world, there will be only a single mapper which will be used. But this diagram is to make you understand that when you are working with large tables, Scoop can divide it and assign it to multiple mappers. This does 2 things. First of all, it makes the entire import process faster because rather than a single mapper working on the entire data, you have 4 mappers or more than 4 mappers working now. And more than that, it also ensures that the structure is maintained based on the primary ID. So here you can have a look at the Scoop architecture. So usually you will be working with Scoop from a Scoop client. So you can have the Scoop client installed in your Linux machine. So in this picture, I have an Ubuntu box and I have installed the Scoop client. One thing that is very important here is that you must have Java installed in the machine where Scoop is running. The reason for that is the entire tool called Scoop is written in Java. So Java support is mandatory for Scoop. So after that, you can see that we have an RDBMS and the Scoop actually connects to RDBMS and generates the metadata. And based on that, the map tasks will be generated, which can copy the data to either the enterprise data warehousing system or Hive, HDFS, or HBase, etc. So here you can see the 3 steps involved in working our Scoop. Now the first step will be to send a request to RDBMS for the metadata. Now the metadata here is the data about the table in the relational database. The step 2 is from the received information, it will generate the Java class. Now that is exactly why we said that you need to have Java installed, because the Java class has to be generated and then it internally uses JDBC APIs to generate the data. In step 3, Scoop post-compiling creates the jar file. However, you understand that whether it is a map job or a reduced job, it has to be in the form of a jar file. Now, Scoop will finally convert your job into a jar file and submit it to the system. Now, as it is written in Java, it tries to package the compile classes to be able to generate table structure, and the jar file will be submitted to the system. So having spoken so high about Scoop so far, let's also have a quick discussion about the limitations of Scoop. Now, the first limitation is that Scoop can only be used for importing and exporting structured data. Whenever you have semi-structured or unstructured data, then well, Scoop is not your choice. And for loading unstructured and semi-structured data, there are other tools such as Flume, Kafka, etc. When importing data into HDFS, the source table has to be indexed on primary key. If not indexed, only one mapper will fetch the data. Now, this is really important. Unless you index it on the primary key, Scoop will not understand how to divide the data. So for example, if you have the indexing on primary key, and based on the key, it can decide how many mappers need to be run. If you do not use primary key, then it will by default use a single mapper to import the data. So to wrap up, in this particular lesson, we have learned about the internal workflow, architecture, and the limitations of Scoop. That's all for this lesson.